So guys, we spoke about, okay, let me recall about it. First we'll finish it off. We spoke about there are different electromagnetic waves. Okay. You know the electromagnetic waves in descending order of frequencies, right? So all these electromagnetic waves have the same speed in air. Correct? All the electromagnetic waves have the same speed in air. What is the speed of electromagnetic wave? 3 into 10 to the power 8 meters per second. That is the speed of electromagnetic waves in air. Or in vacuum, that is the speed of electromagnetic waves. So what are the different types of electromagnetic waves? Radio waves, microwave, infrared, visible light, ultraviolet, X-ray, gamma rays. That is the order in which the frequency of the electromagnetic radiation will be increased. So, which electromagnetic wave has the lowest frequency?
Radio waves.
Radio waves. Who has the highest frequency?
Gamma.
Gamma. Okay. So then, who has the lowest wavelength? Gamma. The one who has the highest frequency has the lowest wavelength, because the frequency and the wavelength are inversely proportional. Then who has the highest wavelength?
Radio waves.
Radio waves. What waves?
Radio waves.
What waves?
Radio waves.
Radio waves.
Radio.
What waves?
Radio.
Radio waves. Okay, yes. So the radio waves have the highest wavelength and the lowest frequency. So the order in which the frequency will be increasing will be radio waves, microwave, infrared, visible light, ultraviolet, X-rays, and then gamma rays. That is the order in which the frequency will be increasing.
So okay. Like as the wavelength increases, the type of wave becomes less dangerous, right? Because
as a frequency,
I mean the wavelength increases.
Yeah, it becomes less harmful. Okay. Correct. So now we are going to speak about, I have given you after that the next subtopic, the role of different electromagnetic waves. Now these different electromagnetic waves are used for what and what. Okay. And then radio waves. Radio waves are used for what? To broadcast TV and radio stations. Okay. So guys, if you are listening to radio, the radio itself is receiving some signals. No, that signals are radio signals. We call them as radio signals. Okay. Then is there anything called TV signals?
No.
Is there anything called TV waves?
No.
No. So even the TV, when you turn the antenna, don't you turn the antenna?
No.
How many of you use an antenna at home? Now, yeah. In the modern day, okay, we don't use antennas. What we actually use is a satellite or maybe a router, which is used. Okay. So guys, let's say you're not using a satellite TV, you're not using dial-up TV or BOTV or some satellite TV, you're not using, you're just using the local channels. Let's say you want to watch the local channels. Say there's a TV and Swagnavahini, Rupavahini, whatever you want to watch the local channels. Then you don't need a satellite TV. No, you just need the local antenna. So then when you have the local antenna, sometimes you need to turn the antenna on. So by turning the antenna, what are you doing? You are turning it so that the antenna will pick the correct signal. Correct? So now these signals are coming from, now forget about the satellite TV, you are using an antenna and its antenna is connected to your TV. So how do you watch these TV channels? How do you watch this Rupavahini and ITN and So how does the picture come into the TV? From where does it come? It comes from, let's say, Rupavahini. It comes from the Rupavahini station, right? Rupavahini, they have a station, or ITN, they have a station, right? So from the Rupavahini station, the signal has to come to your house, right? That comes in the form of what?
Radio.
It comes in the form of radio waves.
So,
okay. So the type of wave that comes and reaches the antenna is that you call as radio waves. Exactly. It is a type of wave. which has the highest wavelength and the lowest frequency. So the radio waves are used for what? To broadcast TV and radio stations, radio channels. And the next one, microwaves. Microwaves. What is the type of microwaves are used for what? One is definitely used in the microwave oven is microwaves. So which is for cooking purposes. Okay. And satellite communication. Now what is this satellite communication? Now those who are using dial-up TV or POTV or whatever, that they would have come and fixed a small dish-like thing on top of the roof or the rooftop or whatever, they would have fixed it, right? No? How many of you using dial-up TV? How many of you using POTV? Any other satellite channel thing you are using? Dish TV. Yeah. So what is this doing is listen. Yeah. Upside umbrella. Yes. So that dish is collecting signals from the satellites. From the satellites. Where are these satellites?
Up in space.
Up in space. Circling where? Orbiting the Earth. Very good. So guys, it is kept at a height of about 30,000 kilometers or something, if I am not mistaken. 30,000 kilometers away above the Earth's surface. There are satellites located. Okay. So now the signal that the channels that we watch, sometimes from Sri Lanka, from Colombo, you can watch channels which doesn't belong to Sri Lanka. From Sri Lanka, you can watch a signal, you can watch a channel which is telecasted in UK, no, or even India, or Bangladesh, or Malaysia, or America, or whatever. You can watch foreign channels because from those stations a signal goes to the satellite, which is located in the space, and from there the signal again comes back to Sri Lanka or whatever the country you are in. So that signal goes to the satellite and comes back. What is that signal? That is microwave. That is microwave. Okay. So in satellite communication, what is used is microwaves, and also telecommunication. Telecommunication, the signal used is microwave. Okay. Right. Where is infrared used? In remote controllers. Okay. In security cameras, heaters, security alarms, those are infrared. And ultraviolet is the light which is coming from the sunlight. Okay. X-rays is used in X-ray images and in security scanners.
Sunlight is ultraviolet?
Yeah.
Sunlight. So how can we see?
It's a mix of both. Okay. Gamma rays are used for what? For treatment of cancerous cells. Okay. Gamma rays are used in PET scanning. So I just want you to take it down, the uses of different role of different electromagnetic waves. So take down these, and under that write down these.
Some people say that that's a constant radioactive, but as we see in this case, molecules actually just harmful and
Yeah.
life.
Yeah. There's nothing to be worried about. Wait. First copy this part.
It's just a sneeze. I have not. So,
the visible light is used to see. So I didn't write about visible light. Obviously, visible light is what we use to see. So nothing to write about that.
sir, can I whisper that?
No, no. Just a minute. It's just write sunlight into that. Okay.
So we
Done.
the last part. X no. No. No.
Right.
Yes.
Okay. So guys, that's all was remaining from that. So I told you I want to do a. Yeah. What should I do? So I'm going to talk about a topic, a small subtopic. Write down the topic. So cancer treatment. Resultant of two vectors. Write down the topic. Resultant of two vectors. Resultant of two vectors. Okay. Resultant of two vectors. Right. Do you all have the protractor with you? Who has a protractor? Those who have the protractor, please put your hands up.
I can forget.
Okay. So we will be needing a protractor. At least try to share and do it. Okay. So write down the topic. Resultant of two vectors.
What's the dumbest science meet the dumbest science meet that we say the number that people who believe that Earth is flat? Or like who think that vaccines are bad or something?
Okay, now listen. So guys, now let's. What are vectors? What are vectors? Physical quantities which have both magnitude and a direction. No, size and magnitude. Size and magnitude are the same. No, a vector. What is a vector? A physical quantity which has both magnitude and a direction.
What's magnitude?
Size. Okay. Then what is a scalar? Quantities, physical quantities which only have a magnitude. Okay. So now tell me a few vectors. Force. Force is a vector. Velocity.
Yeah.
Displacement. Acceleration.
Yeah, resistance.
So that comes under force. No? So all those are. Friction is also a force. So that is also going to be a vector. Okay. So all the forces are vectors.
Dissolving. The act of dissolving. A molecule, molecules.
Yeah.
So
So acceleration is a vector. The weight means a force. So that is anyway a vector. So guys, now listen. So how do we find the resultant of two vectors? Okay. We have to wait. So how do we find the resultant of two vectors? Listen. Now let's say there's a force of 5 newtons in this direction. Okay. There's an object. You apply a force of 5 newtons in this direction. And another person applies another force of 10 newtons in the same direction. Then what is the resultant force acting on it? 15 plus 10. 15 newtons. Anyone can understand that.
So it's not 15 plus 10 is 5 plus 10.
Yeah, 5 plus 10, 15. 15 newtons.
Just say that.
Okay, so it's 15 newtons. So if it is in the same direction, you can add them. No harm. Let's say there's another object. You are pulling with a force of 20 newtons. And there's another sycophant here on the other side. Applying a force of 8 newtons in this direction. Now what is the resultant force? It will be 20 minus 8,
12.
which is 12 newtons. 12 newtons to the right. Okay. So 12 newtons to the right. Okay. If you put the direction, fine. No? Any baby can understand that? Are there babies here who can't understand that?
Kind of baby.
Any baby can understand. Huh? It's 12 newtons because it's in the opposite direction, you subtract. Okay, no? Now my question is, now let's say there's a force of 4 newtons applied this way on this object. And perpendicular to that, there's another force of 3 newtons applied on the object. 4 newtons and 3 newtons both are perpendicular to each other. Now what is the result?
1 Newton.
Huh?
1 Newton to left.
Who is telling 7? Who is telling 1? Why 1? Why 1?
7.
Anyone with a different answer? Very good. No, listen. So if they are in the same direction, you add the vectors, fine, correct. You add the forces, correct. If they are in opposite direction, you subtract the forces, correct. But if they are perpendicular, you can't add or subtract. There's a way of finding it. So what we do is, you have to take one vector and draw a line of 4 newtons. And at the end of it, you draw the other force, which is 3 newtons. Now these two are perpendicular. So the resultant force is given by this length. The resultant force is given by this length. Okay. So how do I find this length? I can use, since it is a right angle triangle, I can use the Pythagoras theorem. Understood? So if square I can use is equal to 4 square plus 3 square. So if square is equal to 16 plus 9, if square is equal to 25, if the resultant force is equal to 5 newtons. Yeah. So the resultant force will be 5 newtons. Is that clear? Understood?
Yes.
Okay. So if they are in same direction, you add the two vectors. If they are in opposite direction, you subtract the two vectors. That's fine. And if they are perpendicular, you need to do this. Is that clear? You okay? Understood? Right. So the question, your subtopic was resultant of two vectors, right? So guys, write under that another subtopic. Resultant of two vectors. Yes. Small space and right. The resultant of two vectors when they are perpendicular. Resultant of two vectors when they are perpendicular. Okay. So guys, I want you to take down this one where you need to show the two forces are perpendicular. Check it out. So here the resultant force will be acting in this direction. Resultant force will be acting in this direction. Okay.
One of our previous classes, we know that the case of one arrow is a thing. But for the resultant, it's the head of the thing.
Yeah, so the head of this one, the head of this vector here, it's connected to the tail of this one, right? Yeah.
No, the resultant.
No, resultant doesn't come under that. So you two vectors are there means you take this one, and where the head of that is connected to the tail of the other. Okay, and the resultant is from this starting point to this ending point.
Can it not be the other direction?
No, it should be from the starting point to the ending point. Okay. Take it down, I'll explain to you with a couple of more examples. Take it down. Answer. Right. I repeat, listen. So there are, how do you decide on the direction? So now 3 newtons is this way, the 4 newtons is this way. So first I derive the 4 newtons. And where I'm ending the 4 newtons, from where I'm stopping the 4 newtons, I will start the 3 newtons. From where I'm stopping the 4 newtons, I will start the 3 newtons. And then the starting point to the ending point, that is going to be the result. The direction will be from the starting point to the ending point. Okay. It doesn't matter, even if you do it other way around, still you will end up with the same answer. Okay. Too cold?
No.
Okay.
So, after previous pieces, what's the thing that you notice? But thanks.
You say whatever you thought.
Right. Why I'm putting f square? Because I'm using Pythagoras theorem for this triangle, right? So if I use Pythagoras theorem, 4 square plus 3 square, that is what equal to f square, right? The Pythagoras theorem, a square plus b square equals c square.
So, 1, 6, 5, 6.
Hmm?
5, 6, 4 square.
Because this is 4 newtons, this is 3 newtons. So 4 square plus 3 square, that is equal to this f square. So that is the theorem, Pythagoras theorem. Okay, guys, write down an example. Write down a question. Calculate resultant force. Resultant force acting in the following. Indicating the direction. Calculate the resultant force acting in the following, indicating the direction. So there's part A, let me take. Yeah.
So, I will
there's a force of 6 newtons acting this way, and a force of 4 newtons acting this way. Let's get the answers to 2 decimal places, okay? And part B. There's a force of 6 newtons acting this way, and 4 newtons acting this way. No, wait, I'll make it not 6 and 4. I'll make it 6 and 3. Give a try. Use a ruler.
That one answer.
Yeah. So guys, this one, part A, I'll help you with the part A. You need to draw now the triangle like this. So first I will draw the 6 newtons. And from where I am ending the 6 newtons, I will have to draw the 4 newtons downwards. Okay. 6 newtons here, 4 newtons this way. From where I'm ending the first force, I draw the second one. Okay. So the resultant will be given by, from this starting point to this ending point. So this will be the direction of the resultant force. So indicate the direction of the resultant force with double arrow. Okay. Now to find the resultant force, value of the resultant force, I can use F square equal 6 square plus 4 square. So F square equals 36 plus 24. So F square is equal to 60. So F is equal to square root of 60. So what is square root of 60? Oh, sorry, my bad. 4 square is 16, my bad. F square is equal to 36 plus 16, which is 52. So F is equal to square root of 52. Square root of 52 is 7.21 Newton. That is the result. If you draw another triangle only, you can mark the direction of the resultant. So in order to mark the direction of the resultant, yes, you will have to draw another one. Okay. Okay. So the next one, part B, 6 newtons, I will mark the 6 newtons first. Then from where the end of 6 Newton, where you're stopping the 6 Newton, you draw another 3 Newtons. So the resultant is given by, from here to here, starting point to the ending point. I will mark that as R, the resultant. Okay. So the resultant is given by R square equals 6 square plus 3 square. So R square equals 6 square is 36, 3 square is 9. So 36 plus 9 is 45. So R square is 45, means R is equal to square root of 45. How much is that? 6.7. 6.71 newtons. Is that clear? Yes. Correct? Done?
No, wait.
Okay. So guys, now write on the next subtopic. Resultant of two vectors. Resultant of two vectors when they are not perpendicular. If they are not perpendicular, how do you find the resultant? Okay. Now listen to me. Now stop all your work and listen to me. Now for this, definitely you need the ruler, pencil, and the protractor. Okay. If you are not having the protractor, please share it with someone. You can't do it without the protractor. Okay. Chill. Peace. Okay. Now guys, let's say now there's a force of 50 newtons this way. Okay. And there's a force of, let's say, another 40 newtons this way. Okay. And let me say the angle between them, between the two forces, is about 60 degrees. 60 degrees. Now I want to find the resultant of these two forces. Okay. I want to find the resultant of these two forces. This is how we do it. Listen to me. Stop your work and listen. I will tell you the steps. Properly follow the steps. If you don't do it accurately, the answer is going to be wrong. Okay. So there are two forces, 50 newtons and 40 newtons, the way they have marked. And the angle between is 60 degrees. We use a method called scale diagram. Okay. So first we'll decide on a scale. I will use a scale here. 10 newtons is equal to 1 centimeter. I will take 10 newtons is equal to 1 centimeter. So 10 newtons is 1 centimeter means 50 newtons is 5 centimeters. 40 newtons is 4 centimeters. Correct? So 50 newtons is to the right now. So I will draw a line of exactly 5 centimeters. You have to draw exactly 5 centimeters. Okay. Then from where you are ending that 5 centimeter line, where you are stopping that 5 centimeter line, with an angle of 60 degrees, with this line 60 degrees, you measure accurately 60 degrees with the protractor and draw another line of how many centimeters? 4 centimeters. I repeat, you draw the first vector. From where you stopping the first vector, you start the second vector. From where you have stopped the first vector, you start the second one. Okay, and you draw exactly 4 centimeters here. Correct? You have taken both the vectors with the correct scale, with the correct angle. So if you have taken it with the correct angle and the correct scale, this starting point to this ending point, that's going to give you the result. Okay. And then you need to use the ruler and measure this length. Okay. Yes. I will tell you what to do after that. For now, wait. First, take down this one. After that, you can do. Now share the composite protractor. Where is it?
And then master class, so my school bag is downstairs.
Wait, take it. I repeat, guys, listen. So now the question is this. There are two forces. One is 50 newtons and the other one is 40 newtons, and the angle in between them is 60 degrees. That is the question. So now I want you to find the resultant of these two vectors. So first you decide on a scale. So I have taken a scale of 10 newtons is representing 1 centimeter. Okay. And then you first draw the line. 50 newtons will be represented by 5 centimeters. You draw a line of 5 centimeters. And from where you have ended that 5 centimeter line, from where you have ended, you draw another 4 centimeter line at an angle of 60 degrees. At an angle of 60 degrees, you draw a line of 4 centimeters. So after that, you connect this starting point to this ending point. That will represent the resultant. I will tell you what to do after that. First, complete the diagram. Complete the diagram. Use the protractor definition. Make the protractor. Okay, go on to track. One. We have. Where's one? Anyone else know? Second and one. Done. Right, okay, done. Wait. Are you done? No. I want you to tell me what is this length? Guys online, what is the length you are getting for this? 7 point. 7.8. Okay, let's say if it is 7.9, you stick to 7.9. If it is 7.8, you stick to 7.8. Let's say it is 7.8 centimeters. Okay, then the resultant will be 7.8 multiplied by 10. Why is that? Why is it multiplied by 10? Because we have taken a scale of 1 centimeter representing 10 newtons. So 7.8 centimeters will be representing 78 newtons. That will be the resultant in that case. If you had got 7.9, you stick to that. So it's going to be 7.9 into 10. I don't know, I didn't do it, so I can't tell you whether it's right or not. So if you have measured it properly, you can't go wrong. So what is the direction? The direction is always from the starting point. We started from here, no? Starting point was here, the ending point was here. So this is going to be the direction of the result. Understood? So if you want to definitely measure the angle, you can measure this angle and tell me what is this angle? How much is that angle? How much is that angle? 30. Huh? 30. So it is at an angle of 30 or 40 or whatever the angle with the 50 Newton force. 26. So that's going to be the resultant, direction of the resultant with the 50 centimeter force, with the 50 Newton force. Is that clear? Understood?
Sure.
Any questions?
Yes.
Any questions, anyone?
No.
All okay?
Yeah.
So we'll do another couple of more examples. Right? Okay.
No.
Right.
No.
So the next one, I will take a force of 80 newtons this way, and a force of 50 newtons this way, at an angle of 40 degrees. Okay.
Yes.
No, I think for the previous one, it was anyway about 26. That's correct. So, what do you think is a good scale here? We can stick to the same scale. We'll take 10 newtons as 1 centimeter.
Sure. Can you do the next question with any tool?
Huh?
Can you end with that tool instead of a zero? Next question. So I could understand. Like 52.
So, we'll take a scale of 10 newton representing 1 centimeter again, and finally tell me the result.
Please go some.
Okay, do it. Yes. You start with 80 newtons. Then 50 newtons where you know that. Okay, let me repeat, guys. Listen here. See, guys, listen. Now, listen. I see a lot of people doing it wrong. 80 newtons will be represented by how many centimeters? 8 centimeters. So, without thinking anything, just first draw an 8 centimeter line. You draw an 8 centimeter line. From you, where you are ending the 8 centimeter line, you will have to draw another 5 centimeter line, which is at an angle of 40 degrees below that direction. So from here, you have to measure 40 degrees. It's going to be something like this, isn't it? So this has to be 40 degrees. This angle is 40 degrees. Correct? From the right, you measure the angle downwards 40 degrees. So because the 50 newtons is down, no? 40 degrees below that initial force. So you measure exactly 5 centimeters here and represent the 50 Newton force. Okay. So from this starting point to this ending point is going to be the resultant. This is the starting point. This is going to be the resultant force. So how much? How many centimeters is that? Okay, okay, do it. Measure it accurately and do it.
Then you want that, like,
I want the actual.
like a perfect, like, even if it's point.
Try to get it accurately as much as possible. What are the length you are getting? 12 point? 1, 2. What is the length you are getting? What about it? 12.4. Okay, fine. Okay, you stick to your value, no problem. So the resultant is going to be, now let's say this is 12.4 centimeters. Then the resultant will be 12.4 multiplied by 10, which is 124 newtons. Okay. So you stick to your value, whatever 12.4 or 12.2, whatever. Okay. So the direction of the resultant will be, you can measure this angle and tell me now. What is this angle? This angle? Huh?
No, not this.
Angle. What is the angle you are getting? 10 degrees.
10.8.
10.8? How can you measure 10?
I got 50.
15.
60.
Exactly 40.
60.
I got 80.
You all know how to use a protractor, right? What is the angle again?
140.
Huh?
I got 140.
So that means between 10 and 11. 15. 15.
So which angle is that?
This angle.
Oh.
I got 80.
I got 10. Yeah, 10.5.
15. Can't be 10.5. This between 10 and 20 means it's 15.
Oh yeah, 15. I got
Fine. Okay. Shall we try another one?
Yes.
exactly 15.
So the next one.
Yeah, make it extra. Make it so hard that even you find it hard. So the real challenge. Give us a real.
The real stuff.
Okay. So guys, now these are the two forces. I'll take this one to be 75 newtons. This to be 60 newtons. And this angle, I'll take it as 30 degrees. Okay. 75 newtons upwards to the north. And from with that, at an angle of 30 degrees, there's a 60 newtons. And I wanted to find the result. Can you tell me what is a good scale here? Same scale we can stick to. 10 newtons is 1 centimeter. With this scale, give a try.
So please give us.
Tell me the values.
Don't.
3.7.
13.
No way.
Okay, good.
No way.
Good.
No way.
13.
You want that stuff? The Resultant Force.
What is this?
No way.
Good, good.
Correct. Right. But when you do that, you don't find the direction. When you turn it, you don't find the direction. So please,
give me some more time.
some more time for what?
I'm just about to find out the answer. Don't know this one is. For once.
What garbage are you drawing? Guys, now see, you sycophants. For nothing sycophants. Listen. Now 75 newtons you will be representing with how many centimeters?
7.5.
That is vertical, no? No? So you draw vertical 7.5 centimeters. Correct? A vertical 7.5 centimeters. Right? So from where you are ending that 7.5 centimeters, from where you are ending it, you have to draw this 60 Newton. 60 Newton will be how many centimeters? 6 centimeters. With an angle of 30 degrees with the initial direction. So from here, I'll put a dotted line for you to see. From here at an angle of 30 degrees, draw another 6 centimeters. This is 30 degrees. With an angle of 30 degrees with the initial direction, you draw 6 centimeters. Correct? So the resultant is going to be from here, this starting point to this ending point. Wait, don't disturb me. So this is going to be the resultant. How many centimeters is that? Yeah, looks right. How many centimeters is that? 13 point? 13 point? Okay, 13.1 centimeters, let's say. Okay, you stick to your value. Okay. So if it is 13.1 centimeters, the resultant is going to be 131 newtons because 1 centimeter is representing 10 newtons. Correct. Stick to it. So if you are to get the direction, okay, if you are to get the direction, let's take this angle. How much is this angle? How much is that angle?
About
14, 15 or what? 14. So it's 14 degrees with the 7.5 centimeter force, 7.5 centimeter line.
No, not 40. It's 13.5. 13.5.
The first page of this subtopic was this one. Okay. Any questions, anyone? Any questions? All okay?
Yes, sir.
60 newtons is connected from the bottom. When finally the resultant is drawn.
So the angle is.
That is what I have been telling all this time. You don't see whether it is connected at the bottom or top or what. From wherever you are finishing the first force, from where you are ending the first force, you start the second force. So I drift the 7.5 centimeter line and I ended the line here, right? So I start my second force from there. So that is what I have been doing in all the questions so far. I draw the initial line from where I am ending the initial line and start the second one. Okay. Yes.
Sir.
You want to try one more?
Yes. I can do it. No, say yes. Yes.
We'll try one more.
Yay.
We'll try one more and take a break. Huh?
So you are the best. And the best.
Favorite time.
No, see?
There's a force this way. And this is, I will take it as 0.7 newtons. This I will take it as 0.5 newtons. This I will take it as 45 degrees. Correct. So what is a good scale here?
0.1 equals 1 centimeter.
What is a good scale here?
0.1 equals 1 centimeter.
We'll take 0.1 newtons equals 1 centimeter. Zero 0.1 newtons equals 1 centimeter. Give a try. Give a try. Sorry. Okay. Done. What's the answer? Tell me the final answer. I need the final answer. Let's see. So guys, now 0.1 newtons is represented by 1 centimeter. So 0.7 newtons, we will draw a line of 7 centimeters. Draw a line of 7 centimeters. Then from where you are ending that 7 centimeter line at an angle of 45 degrees, 0.5 newtons will be represented by 5 centimeters. From here you draw a line of 5 centimeters. Where this angle will be 45 degrees. Okay. So the resultant will be from this starting point to this ending point. How many centimeters is that? 11 point. Let's say 11.1 centimeters. So if it is 11.1 centimeter, you need to multiply 11.1 with 0.1 because 1 centimeter is representing 0.1 newtons. So 11.1 into 0.1 will be 1.11 newton. Okay. Is that clear? Okay. Fine. Then you can take a break. We'll be back in 15 minutes. We'll come back and do it. So we are going to start a new topic. What is the topic? You gave me that, sir. Pass it behind, pass it behind. Take one and pass. Hi, people. Hello. Okay. Right. So, guys, online, I have sent you 3 tubes from electricity. One is this tube, where on the page 1, which is a theory tube. Page 1 on the top left, it says electric circuits. Take that tube. Did you all get the tube? Did you all get the tube? Right? Fine, okay. Somehow we are getting it. Is there any way? Okay, guys, now listen. Right. Okay, guys, electric circuits. Now, what is this? What is this electric current means? What?
The flow of electricity.
The flow of electricity. What is this electricity means? What?
The energy created by the flow of electrons.
Flow of
Electrons.
electrons, correct. So, guys, an electric current means it is a result of flow of electrons. Okay. Electrons, they have a charge.
Yes, negative.
Positive or negative?
Negative.
It's a negative charge. Okay. The tube is sent in the mail. Check the mail. Okay. Electrons are negatively charged. So the result, as a result of these electrons are flowing, we call that there is an electric current. Okay. Correct.
Yes.
Can you touch an electric current? Have you tried touching?
And what you're trying to ask.
Okay.
You can.
You try catching electric current.
That one time I got shocked. So you know those.
So that is like your hobby.
Not hobby.
Then?
Once when I was a kid.
Once it was your hobby.
That's my hobby. I just got shocked once when I first touched the current
Why did you touch the current?
because I was curious.
Because that was your fun.
No, I didn't know what the current felt like at the time.
You wanted to smell it and see. You put it in the nose.
No, I put my finger to the like.
Put the finger where?
Now, you know,
It's a child-friendly class.
you know how some switches.
Yeah.
Like when they hold the switch part gets electric charge. So I saw one and decided to touch it.
And you was
You decided to touch what? The switch.
Yeah. And I was
Okay.
shocked.
You touched the switch and got a shock.
Yeah.
No. What?
Because I was curious to see what the electric shock could be like.
So touch this part and
So are you still curious about it? Do you want to try again?
No,
Come.
No, not really.
No.
Not anymore. I just use back in the day.
I don't like
Okay. So
It's like a very fast vibration. Electric shock.
Hmm.
It is.
Saw it in the movie.
Like,
how many of you have gotten electric shock? Put your hand there. How many of you have gotten electric shock?
oh, what? So
Okay.
your tongue.
How did it feel like? It was an amazing feeling, is it? It was nice. Yeah.
So it's like when your finger gets an electric shock,
Yeah.
it's like your finger vibrates at supersonic speeds. It vibrates so much it feels like your muscles are flipping apart. It's that fast. Like
How did it feel like?
Yes, like
Oh, don't Don't spoil the chat. It's painful, huh?
No, it's heavenly.
It's heaven.
Okay, guys, now listen.
It's
So,
love serious.
would you like to come and speak about?
Egg roll, no, no.
Egg rolls, yeah. I can say teach about egg rolls.
Okay, now listen. So, guys, now what is an electric circuit? Let's go through this. The flow of electric charges is considered as an electric current. Okay. For an electric current to flow in a circuit, two things are needed. For an electric current to be flowing in a circuit, two things are needed. What and what?
Wires and electric source.
The circuit, the number one, the circuit should be completed without any flows in it. Okay.
Yes.
There can't be breaks. It should be a completed circuit. Right? And the number two, a source to push the charge around the circuit. Usually it is provided by a cell, battery, or a power supply. Okay. So two things are needed. One is a completed circuit is needed. Okay. A completed circuit is needed. And the other one is a battery, something to supply power is needed. A battery or a cell or a power supply is needed. Okay. Okay, hold on. Give me a minute.
E. Then you do an A. Papers or to new.
I will just
Right. Electricity.
Okay, I have sent you the code.
Why electricity of sense success?
Set what?
Sense success.
And he really better see.
Okay. So guys, listen. Then the next one. A battery is two or more cells connected into it. What is the battery? If you take two or more cells and connect them together, you call it a battery. A battery is two or more cells connected into it. Current flows from blank terminal of the battery. It flows through the circuit and will come back to the blank terminal of the cell or the battery. Such an electric current that flows in the same direction all the time is known as a blank. Wait. Current flows from which terminal to which terminal? Positive to the negative terminal. Okay. So let's complete the blank. Current flows from positive terminal of the battery. It flows through the circuit and will come back to the negative terminal. It will come back to the negative terminal of the battery. Such an electric current that flows in the same direction all the time is known as a, you call it as a direct current. You call it as a direct current.
So do you recommend like while you are having a head redo all the activities?
Listen. So guys, if there is a current flowing in the same direction and if it is continuously flowing in the same direction, the same value is flowing means you call it as a what current? Direct current. Understood?
Doesn't eventually run out the
Yeah, if the battery charge goes down, then it will just run out. Who's asking me? The battery has stored chemical energy in it now. So energy is conserved. So you can't create energy. So the chemical energy stored in the battery is what? Turning out to be electrical energy. So if you keep on using the battery for a longer time, it will discharge. Eventually, the charge in the battery goes to zero. So then you can't use the battery anymore.
So then it goes and comes back to the negative, right? Like of the battery.
Yes.
The chemical, like whatever chemical that goes want to go to the negative and so.
No, the energy is not coming back to the same battery. No, what is coming back is the electron. The charge is coming back to the battery. So the charge carries the energy from the battery and goes and give it to the equipment, the light or the fan or whatever. It goes and gives the energy and come back without the energy.
Oh.
It gets the energy again, goes, give the energy and come back without the energy. So eventually the energy stored in the battery will go to zero.
Oh, so like it's like when non-oxygenated blood goes to the alveoli, right?
Non-oxygenated bulb.
Blood. Non-oxygenated blood goes to the alveoli, takes in oxygen, and then goes back to the body to transport
Correct.
oxygen.
Something like that. I get it. The next one, the following two figures show the same circuit, one with switch open and the other with the switch closed. There are two circuits here. In one, the switch is open, the other one, the switch is closed. In which one is the switch open? Here, see, can you see here, this switch is open. There's a gap here. So then, this is the circuit symbol for a switch. Okay. So in the first diagram, the switch is open. In the second diagram, you have closed the switch. So where the circuit has become closed. In the second figure. So tell me, in this first figure, will there be a current flowing?
No.
Why not?
Because there's a gap.
Because
there's a gap in the circuit.
the circuit is incomplete. So if the current is coming from the battery, after coming to this point, it can't continue. No, there's a break. So that means, since the circuit is incomplete, there won't be a current flowing in that. Understood?
So on the battery give like over chemical energy.
Huh? Chemical energy is converted to electrical.
Yeah, that's it. Like while it stays in one place without being given to something.
No. There won't be continuation of current.
So how does the battery
No, that is the mechanism of the battery. We don't study about that. So what is inside the battery, that we do. Okay. Right. In figure 1, there will be blank flowing since the switch is blank and the current is blank. In figure 2, there will be, right, the first one I will complete this statement. In figure 1, there will be no current flowing. Shall I make a small correction, please? There will be no electrons flowing. In figure 1, there will be no electrons flowing. Since the switch is open and the current is 0. Okay. In figure 1, there will be no electrons flowing since the switch is open and the current is 0. Correct? And the next statement, in figure 2, there will be blank flowing from where to where? Terminal of the cell, since the switch is open and the circuit is right. Tell me, in figure 2, there will be electrons flowing or current flowing? I will tell current flowing. So I will write it as current flowing. Listen. Flowing from which terminal to which terminal?
positive to negative?
Positive to negative terminal of the cell. Positive to negative. Terminal of the cell. Since the switch is closed and the circuit is complete. In figure 2, there will be current flowing from positive to negative terminal of the cell since the switch is closed and the circuit is complete. Okay. Let's turn to the next page. Electric conductors. electric. I mean, you could have written electrons, but then if you had written electrons flow from the negative terminal to the positive terminal. Current flow from the positive terminal to the negative terminal. Okay. Right. Right. The next page, electric conductors. Electric conductors are materials which allow the electric current to pass through them. Electric conductors are materials which allow the current to pass through them. It can be categorized as good conductors and bad conductors. There are good conductors and bad conductors. So what are good conductors? Which let the current pass through them easily.
Iron.
Okay.
Is it a good conductor?
So I have written here, wait. Good conductors allow the electric current pass through them easily, and bad conductors do allow the current pass through them, but not very well. So those are bad conductors. Okay. And there are materials which don't allow the electric current to pass through them. These materials are known as, you call them as insulators. There are materials which don't allow the electric current to pass through them. These materials are known as insulators. Not now, wait. Okay. The following are few examples of conductors and insulators. So the good conductors are copper, silver, gold, steel. These are good conductors. Okay. Bad conductors, liquids are bad conductors. Okay. They conduct, but bad conductors. Insulators,
They don't.
yeah. So what are the material examples? Plastic, glass, perspex.
What's
Publics, these are materials, the type of material which doesn't let the current pass through them. Okay. So that is the reason you will see when people are working, especially with current, they wear rubber boots. Why? Because rubber is a good insulator. Or even plastic, even glass is a good insulator. It doesn't let the current pass through it.
So what does perfect say? Can be
That's a material
like where can you find it and what does it?
which is used to make lenses. The lenses are sometimes made of that.
Oh, so like it's like a glass. Like, oh.
Sir, why are red humans good conductors, but why are humans good conductors?
Humans are not really good conductors. Conductors.
Are they good insulators?
No, not insulators.
So why is that?
So the human body is made of in such a way it let the current pass through it. So it is not an insulator, but it's not a very good conductor also.
So that
Okay. Right. Guys, the next one, next subtopic. Electric current. The rate of flow of charge is known as the electric current. The rate of flow of charge is known as the electric current, which means the amount of charge flowing through a point in 1 second. The amount of charge flowing through a point in 1 second is what you call as the electric current. So the electric current is, as an equation, current equals charge flowing over time taken. So I equals Q over T. Okay, you can write it as an equation here. I equals Q over T. Yeah. Then the next point, electric current is measured in amperes. Electric current is measured in amperes. It is the SI unit of current. What is this? SI? Standard international unit of current. Smaller currents can be measured in milliamperes or microamperes. Milli or micro. Okay. So a milliampere means how many amperes? 10 to the power minus 3 amperes. Okay. A microampere means 10 to the power minus 6 amperes. Okay. To measure the electric current, an ammeter can be used. It can be an analog or a digital ammeter. So an analog ammeter looks like this. A digital ammeter straight away gives you the value of the current. So the analog and the digital ammeters pictures are given here. Okay. Right. So guys, we'll continue from this point on the next day. And most probably I'll be giving you the paper that you did last week. You will be getting it. This is the previous week. So guys, that's it for the day. Have a nice week ahead. See you next week. Bye. Take care.